Okay, so the second part, we're going to talk about complex conjugates. And if you notice in the last section, some of the problems, when you multiplied them together, the i's canceled out and you were left with a real number. Those are called complex conjugates of each other. And complex conjugates are when the I term is the opposite sign. So if I have A plus BI, its conjugate is A minus BI. So A plus BI and A minus BI are complex conjugates. And what we know are complex conjugates multiply to be a real number. So even though it's two imaginary numbers being multiplied together, they multiply to be a real number. So the next thing we're going to go over is dividing complex numbers. And when you have a complex number in the denominator, because there's an I in the denominator, that means there's a radical in the denominator. And you're not allowed to leave a radical in the denominator, a square root in the denominator of a fraction. So what you're going to do is multiply both the numerator and denominator by the denominator's complex conjugate. And what that will do is it will eliminate the I in the denominator, so now you're allowed to leave it in that simplified form. Okay, so here I have the complex number 9 plus 12i being divided by 3i. So I need to get rid of that I in the denominator, so what I'm going to do is multiply by that denominator's conjugate. And because it's just the imaginary part and there's not a real part, the conjugate is just going to be the opposite. But the conjugate isn't always the opposite. It's only the opposite of the imaginary part. So I'm multiplying by that to the numerator and the denominator, which when I multiply it to the numerator, it's a binomial times a trinomial. So I need to distribute. So that's going to become negative 3i times 9 becomes negative 27i. And negative 3 times 12, well, that's negative 3i times 12i is going to be negative 36i squared. Divided by 3i times negative 3i becomes negative 9i squared. And then I'm going to make the I squareds negative 1. So negative 36 times negative 1 becomes positive 36. And because that's my real part, I'm going to write that first. Okay, so the 36 becomes the real part. The imaginary part is the negative 27i. So that's 36 minus 27i. And then negative 9 times negative 1 becomes positive 9. And then check to simplify. If anything goes into all three of these. If you can divide by a common factor to all three, in this case it is 9, so my solution is 4 minus 3i. And that's my simplified form. Sorry, not my solution, my simplified form. Okay, so here's one where my denominator is a binomial with the real part and the imaginary part. I'm still going to multiply by the denominator's conjugate, which is 1 plus 4i. And when I do so, I'm multiplying a binomial with a binomial, so I'm distributing twice. 2 plus 8i plus 3i, that's there, and then plus 12i squared. In my denominator, I'm going to get 1 times 1 is 1. 1 times positive 4i is positive 4i. Negative 4i times 1 is negative 4i. And negative 4i times positive 4i becomes negative 16i squared. And because these are conjugates, what should happen is these two should cancel out. I have a positive 4i and a negative 4i that cancel out. Okay, combine my like terms in the numerator. I have 2 plus the 8i and 3i combined to be 11i, and then the 12 times negative 1, the I squared, becomes negative 12 or minus 12. And then on the denominator I have 1, my i's cancel out, and minus 16i squared becomes positive 16. Negative 16 times negative 1 is positive 16, so that's plus 16. I'm running out of room, so I'm going to go to the left and combine my like terms. Positive 2 and negative 12 becomes negative 10 plus 11i divided by 17. I got to check for common denominators, but nothing goes into 10, 11, and 17. So my simplified form is negative 10 plus 11i divided by 17. This also could come up when you're solving by square roots. Okay, so because I only have the x squared term and there's no x term, I can solve this equation by subtracting 32 and getting the x squared term by itself. Okay, in order to get x squared by itself, I now have to divide by 2. And that's going to become x squared is equal to negative 16. And now I can take the square root. Well, before I wasn't able to do this because it's the square root of a negative number. But now I can finish it. And remember, when you're solving, when I take the square root of both sides, I do need the plus or minus. And square root of 16 is 4. But because it's negative 16, it's going to be 4i. And that's my solution. So, for one more. Okay, I got to get my like terms together first. So I'm going to subtract 2x squared. I want to keep that x squared term a positive. So I have 3x squared minus 56 is equal to 25. Add the 56. 3x squared is equal to 81. Divide by 3. X squared is equal to 27. Take the square root. Now in this case, I still need the plus or minus, but it's not an imaginary number because there's not an I in the radical. So when I simplify the square root of 27, I get a pair of 3's, so it's 3 times the square root of 3. A 3 was left over without a pair also. So just be careful that.
Okay, so here are a couple U-try problems. Division and solving by square roots. Remember, if it's a negative inside the radical, to use the I. And the joke for today, what's worse than finding a worm in the apple you're eating? Finding half the worm in the apple that you're eating.